Multiplying algebraic expressions can be extremely useful for us. And what we're going to focus on are binomials. So binomials have two terms. So that's a binomial. This is a binomial. See, 1, 2 terms. This is a binomial. And this is a binomial. And specifically, we're going to look at binomials where the first term is in our variable and the second term is a constant. There can be other expressions of binomials that have greater terms. Now what I want to do is I'm going to show you what it means when we multiply two binomials together. And I'm going to just multiply these two. I'm not going to be worried about larger coefficients out front. But I want to talk about it from the idea. Actually, I'll do a generic one where I'll use a times x plus b times c times x plus d. But I want to go into a little more detail than your textbook is. So what we're going to end up doing is we're going to fill out a technique called FOIL. But first we're going to distribute. And remember, things in the parentheses can be thought of as one thing. And so our distribution law, right, said that if I have something out front, I distribute it to each term inside. And so we'll say this is something out front, so I'm going to distribute it to each term outside or inside. And so this whole thing I've multiplied times cx, oops, sorry, I put my x there, and d. And so the whole thing times these. Now this, I want to bring out front. Because multiplications are commutative, I'll commute it. And then what I'm going to do here now, so I'm going to multiply these inside. I'm going to distribute these. So I'm going to get x times, I'm going to get ax times cx plus b times cx, because this is going to go through each one of these. Then I'm going to get ax times d plus b times d. And so I'm going to look at this long string of multiplications here. And it's going to be a times c, and x times x is x squared. This is going to be b times c times x, and this is going to be a times d times x plus bd. And so these two terms, this has an x squared, and this has no x. But these terms here have to come together. And so I have bc plus AD times x plus BD. And this is how we multiply. But there's a neat trick that can do this for us. One of the things that happened is when I pulled this whole thing in, the first part got multiplied by CX. When I pulled it over here, the first part got multiplied by D. So it was like taking the first times the first, and the first times the last. And that's what we do with FOIL. FOIL talks about the parts and puts them all together. So I'm going to switch colors here, and we don't have to do this long drawn out process, even though it'll work out to the same thing. And I'm going to also make a note that this thing is going to be called the middle term, because it's in the middle of the thing without the x and the x squared. And notice the middle term gets built about with everything. Everything builds up to make the middle term. But the leading term only has a and c in it, and the ending term only has b and d in it. And this is going to help us find our way when we do FOIL and need to go backwards. So it's just a note here that everything gets put into making the middle, and only the last things get put into the last part, and only the first things get in here. So firsts, outers and inners, and lasts. And that's what FOIL is. FOIL says multiply the firsts, then the outers, then the inners, then the lasts. Well, what does that mean? Let's do one. X plus 3 times x plus 4. And I'm going to try to color code these here, so let me color code my FOIL. Firsts, outers, inners, and lasts. So the firsts are these. So the first times the first is x squared. I take the first times the first. Now I'm going to do the outers. Well, this is on the outside, and this is on the outside. So that's 4 times x. And I'm going to add that as my next term. Now I'm going to do the inners. This is on the inside, this is on the inside. So that's 3 times x. I add those. And then I end by doing my lasts. That's the last one, and that's the last one. So 3 times 4 is 12. And now I can collect like terms. I have an x squared and a constant, so they stay the same. But I have 4x and 3x. And so multiplying two binomials gives me a trinomial. It has 3 terms. And it's to the second power. And so things to the second power are called quadratic. And so we are going to be working with quadratic equations which look like this. And what we want to realize is they come from binomial pieces or binomial factors. Let's do another one. I will color code it slightly differently. So we have 3x plus 4 is one of our binomials. And we're going to multiply it by x. Whoops, 5x minus 3. So I'll do my firsts. 3x times 5x, well, 3 times 5 is 15. And x times x is x squared. So my firsts give me 15x squared. Now I'm going to do my outers. So that's an outer, and that's an outer. So negative 3 times 3x is negative 9x. And now I'm going to do my inners. That's an inner, and that's an inner. So 4 times 5x, and it's a positive 4, gives me 20x. And then I'm going to do my lasts. So 4 times negative 3 is negative 12. And now I'm going to collect like terms, which will be the middle terms here. So I get 15x squared minus 9 plus 20 is positive 11x minus 12. And that's my trinomial when I multiply these two binomials together. Now, what we want to do is we want to reverse this process. And the thing that we do in reversing the process is going to be called the AC method. And we're going to want to be able to go from the trinomial back to the binomial. Now there's a couple things to notice in here. This sign, if it's negative, means that my binomials have two different signs. So if the sign by this last term is negative, one of my binomials will have a plus sign in the middle, and one will have a negative. If it's positive, I have two things that could happen. I could have a negative and a negative, or a positive and a positive. So remember, this last thing was only determined by the last term. Well, I'll just put shapes in here right now to represent the terms. And so negative times negative, that's the only thing that determines this, and that would make a positive one. Well, a positive times a negative makes negative. And so the AC method, we kind of want to work our way through to figure out what the different patterns will be. So let's look at some binomials and what they can give us. So we'll start with this one here, x squared plus 7x plus 12, because we know the answer. It's x plus 3 times x plus 4. And so x squared plus 7x plus 12. Okay, this is a plus sign, so the terms have to be either both positive or both negative. Now the middle term is generated by the addition of the outers and the lasts. And so if they're both positive, then this is positive. And if they're both negative, this would be negative. So this is telling me that I'm going to have x plus something times x plus something. Because this is positive, both of these signs have to be the same. Because this is positive, it has to be the plus sign. And so now we're going backwards. We're going from our trinomial into our binomials, or we're going to be factoring. Factoring trinomials, or quadratic equations. Now, remember back here when I said that the last term is only determined by the lasts. So the only thing this last term can be is two numbers that multiply to 12. So my options are 1 times 12, 2 times 6, and 3 times 4. But this middle term gets made out of the middle term here, the additions of that. So I want to find, so if I add these, the possible factors of 12, so these are my factors of 12, and then I add the factors. Well, 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7. Well, the middle term is 7. So that tells me that those were the numbers I was looking for. And that answers what I did initially. Let's do a couple of these and get our bearings for this idea of factoring. For right now, what I'm going to do is I'm going to talk about a quadratic equation. I'm going to talk about the coefficients in front of it. So I have some number times x squared plus some number times x plus a constant. Now for right now, I'm going to have a equal 1. So our things will look like x squared plus 6x plus 8. And I'm going to want to factor this into two binomials. Now since the sign is positive, both of these signs are going to be the same. And since this is positive, these will both be positive. And now I need all the factors of 8. Now all the factors of 8 are 1 and 8, 2 and 4. And I need the ones that add up to 6. Well, 1 and 8 gives me 9. And 2 and 4 gives me 6. So these are the factors I need to use. So I have x in the front and 2 and 4. Now if I FOIL this, again, I get x. I will get back to this. This will return back to this. So these are reversible processes. I can go backwards or forwards depending on what I'm doing. All right, let's do another one where our sign's going to change on us. So I'm going to do x squared plus 2x minus 35. Now, 35 is negative, so I know my signs are going to be different. And it's positive, so I need all the factors of 35 to add up to 2. And I can either keep track of the negative factors here. So what can I do? So I get 1 times negative 35. I get 5 times negative 7. I get 7 times negative 5. And I get negative 35 times 1. And so I need the ones that add up to 2. Well, 1 plus negative 35 is negative 34. 5 plus negative 7 is negative 2. 7 plus negative 5 is 2. And negative 35 plus 1 is negative 34. And so this one adds up to the middle term, including the sign. And so my negative 1 is 5, and my positive 1 is 7. And so that's the factor for this trinomial. All right, well, we need to do something where what happens when the front term is not a 1. And so what we're going to do is we're going to look at what's called the AC method, mainly because that first term was made out of A and C. So what we're going to look at here, let's start with 3x squared minus 20x plus 28. All right, and that's going to be the one we're going to look at here.